Yes, sir. Good evening, everybody. How are you? So before I start, first I want to make a quick survey. So how many of you have practiced the linked list program, the single linked list? One. Good, almost everybody. Has anyone any problem? How about you from the back? Did you try? Is the program running? Did your program run? Okay, so I'm asking this question to honestly tell me if you have any issue. Still, because if you do not understand linked list, then you will not understand stack and queue. So linked list is the foundation of stack, linked list, and stack and queue operation. So if you really understand linked list operation, then it's easy for you. Stack and queue operation are easy. So good that everybody has practiced. Okay, thank you so much. So as we discussed, okay, you know, a stack is a LIFO type. A stack is a LIFO type. What is it called?
Last in, first out.
Yeah, that is called LIFO.
That's the only option.
Yeah, but it has first in, last out, opposite behavior. That means LIFO. That means I remember that was LIFO, last in, first out. Okay, behavior, and it has mainly two operations: push and pop. Okay, the push is add operation. Push is add operation, and pop is delete operation. Okay, and pick is actually make a copy. It's a return. It's copy. For instance, so as we know that a stack is a like LIFO type. Okay, so that means one of the in the last is bottom is closed. So there is only one way to enter, this way, and only that way, another way to exit. Okay, so the item what will be and at the bottom you enter first, that will be that will go all the way end bottom. Okay, then the next element you want in your stack, that will go on top of the previous element 2. The third element will go here. Okay, and so on. So this is your like push operation. While doing your push operation, you can enter only one element or node at a time. You cannot enter 2 elements at a time. Okay, and then when you pop, make a pop, that means you delete one or you remove one from your list. So then if you push the third one, that will be latest one, recent one, and then if you go to pop, then that will be popped. The third one will be popped. So the third elements know that who is next to third, second, right? The third element, it knows that the second element is next to it. The second element will know that who is next to it. Second element is next to 1, and on knows that is next is null. Okay, and there is another operation that is called pick. It returns the top element without removing it from the stack. Okay, so picking is not in general that like pick. We say pick up fruits or vegetable from a garden, right? You pick, that means you take away. But this pick is not that way. It makes a copy. So our operations are simple. Okay, everybody understands push, pop, and pick operations? Basic thing? Okay, so if you understand this, so then let me go through an example with a program. So I have this slide, so please read through this slide, okay? Whatever I will discuss, everything will be on these slides. But these slides do not have complete program, so you cannot run this piece. These code snippets will not run because these are the pieces of code extracted from book. If you read the book, then you will see there are similarities of this code. Okay, so let us go through stack operation first, and then stack has two operations. One of them is called add, means push, and then delete means pop, right? So let me go through as like the previous program. Let me go through an example. Okay. Now I hope everybody by this time everybody knows how to get updated copy of your of a GitHub project, right? Everybody knows how to get a updated copy of a GitHub project. Like for instance, I have my GitHub project here, github.com/CSE1322. So this is the program CSE1322. Yes, CSE1322 review. I have my complete program over here. Okay, so you don't need to keep note. Complete program you can get from GitHub, but give attention please. Understand from here, then you can get the copy. Okay, so for instance, this is the latest copy. So then, okay, so if you already have updated it, cloned it, then what is the command I will give? Just git pull. Git pull, and origin master is the optional one. Just git. Can you see from there? Just I see git pull. Git pull, and then press enter. Then it says my project is already updated. Then if it is updated, then what I will do, just I will refresh my project. I do a right click and then refresh, and then I will get the updated copy. Okay, so I have my stack implementation program here. Stack implementation explained. This is the program. So if I run this program, okay, so it will show me stack implementation explained. Okay, so this is this line. Stack implementation explained, and I have my stack, this is my stack object, and I have some push operation, and after 5 push operation I am displaying all nodes, and then I do have 2 pop operations. Okay, and then I am displaying it again. So far you understand. Let us try. So if I do these 5 push operations, so what will be in my stack? Which one element will be bottom? Okay, so if I do these 5 operations, like AA will be this one, right? With ID, AA will be this one, right? With ID 1, right? Let me see my ID over here and then name here. This one will be here, and then BB will be here, right? BB will be here. Okay, and then likely B, sorry, B here, C here, D here, E here, right? C, D, E will be here, right? Okay, this E will be here. Okay. Okay, so E will be the top one, right? E will be the top one. So then what is next to E? D, right? Here D, right? DD, I have DD here. DD will be next to E, and I have C over CC here. CC will be next to D, right? Okay, and then if I do 2 pop operation, then which of the 2 elements will be gone? If I do 2 pop operation, then which will be gone? E and D, right? E and D will be gone, right? And then I will have remaining C, B, and A. Did you understand? So let us run this program and let us see the output of this program, right? So initially I have 5 nodes. Node with ID 5, name is EE. That will be on the top. Okay, then the next element will be DD, right? EE, that is the last one I put, that is going on the top, and the next element will be DD, right? Then ID 4, DD, who is the next? CC is the next one, and then BB is the next to CC, and AA is the next to BB, and what is next to AA? That is null, right? Okay, now if I do these 2, this is the function of display operations, okay? And if I do this pop operation, 2 pop operations, okay, so after this pop operation, I pop the node with ID 5. There is no way that I can pop the second element, or third element, or fourth element until I pop the 5th element. Okay, so this is why, in my pop operation, I am just saying pop. I'm not fixing any ID. Okay, but it is popping the last element, 5th, and then after another pop, okay, it is deleting DD. So then I will have how many nodes? I will have remaining 3, right? C, B, and A. So that is the basic operation of stack. Okay, so now let us do something like last time. Okay, so I want to delete this entire program, and let me run it piece by piece, compose it piece by piece, and explain it piece by piece. Okay, so let me keep a copy. Give me a second, please. Just keeping a copy. Okay, let me put something, everything deleted, and I will delete this one. Okay, So my program is pretty empty at this point. Okay. So if I run this program, what I will get? I will get only stack implementation explain this sys.out. Okay, I don't have anything. Okay, so then let us try to understand. So this node is the same node that I got from my linked list program. Okay, I explained this node in my linked list program, exactly same thing. End of node class. So every linked list, stack and QE, they contain node element. Okay, so a node element contains two things. One is data and another is another node. Okay, the data can be any kind or any number. So I have explained here this node contains two types of data. One is integer type ID and another is string type name. So if you understand node operation with these two data, then you can add any kind of data. You can add any double type like GPA, okay, or another string type address, or another Boolean type is student or is active. You can add anything, okay. And this is the node element. It is the compulsory one. That means a node is containing itself. A node is containing another node, like recursion type. Recursive method calls itself, right? Same thing. Okay, a node contains itself. So this is a node object. Next is a node object. You can give any name, but node next is a convenient name. Okay, and then I have this node constructor. This constructor just takes ID and name as their arguments and just set up these values. This dot ID equal to ID. That means whatever ID I will put for this node, it will set up for this ID. And this is for display single node. What it is doing, it is displaying an ID equal to ID, name equal to name. So in order to make this display meaningful, we need to override these two string method, right? Right? If you do not override this two string method, your node will not be meaningful. I will show you again in a minute. Okay, so this override annotation is optional. If you give override annotation, that is good, but if you do not give, then still it will work. Okay, actually toString method is defined in the object class. Okay, that's it. This is the end of the node class. Okay, so now I have a node class. If I define object of this node type, that will work. For instance, node n1 equal to new node. For instance, ID 1 and name A. Okay, I'm giving shortcut name in order to save my time. That's it. Okay, and if I declare few more nodes, node 2, node 3, and node 4, and node 5. Okay, so whatever I name, give an ID, give 2, let me 3 and 4 and 5 and A, B, this is C, this is D, this is E. So these nodes are distinct. As we explained that if I display this node will display this value, but these nodes are distinct to each other. That means node 1 does not know who is next to it. If I say node 1 dot display a node, then fine, it will display this value. it will display its value. It's ID equal to 1, name equal to A. It's fine. But if I say who is next to N1, if I say N1 dot next, okay, so then actually it does not know who is N1 dot next. If I say sys out, if I say sys out N1 dot next, then what it will print? It will print null. Okay, so then again, if I say N2 dot next, then still it will print null. If I say N3 dot next, then still it will print null. So everything is null. That means no node knows who is next to it. So this is why if you want to implement your stack by this way, then you have to assign, for instance, you have to assign that value. For instance, that n1 dot next equal to n2. You have to assign this manually. Okay, and then you have to say n2 dot next equal to n3. You have to say n3 dot next will be n4, likely this way. So but defining all of the nodes like this way is not a good way. Okay, so if I define, then it will be fine. It will show me this, who is next to this, it show me. But this is manual assignment is not a good way. So then we need to, like stack operation, we need to create another class that will, while we add a node in our stack, then it will know who is next to it. Okay, so this is why, so this kind of manual operation we will avoid. We will avoid this kind of manual operation. We don't need this. So instead of what we will do, we will create another class, any name we can give my class, but let me give it my name class stack. Any name I can give this stack and of the stack class. Okay, so then once I have my stack class, then I will be able to create stack object. MIS, for instance, my stack class stack object equal to new stack. I will be able to do that. Okay, and then I have my stack operation, my stack, and then what I need to do, I need to implement a few methods over here. What are the methods I need to implement? Push, pop, pick. Okay, and if you want to find size, then you can get size, and other operation is empty or something. Okay, something like. Okay, so this stack class with by default will contain a node element. Node, I say top. This stack class will contain a node element. So if I see that you are watching on your computer screen, okay, that I guess that you are watching this video or lecture sheet. But if you open your cell phone, then I have doubt that you are doing something else. You are watching something else. So if you cannot stop your behavior, then this class will not be a good fit for you. Okay, just wasting your time. I'm sorry. Okay, so what are the operation I need? Push, pop, and then other operation, right? Yeah, for instance, but I need on class is that called constructor. Definitely I need a constructor, right? So this is the stack constructor I need. That constructor is optional and it will make the top null. So initial node, it will make the top null. Okay. Okay, start as a null. Okay, then I need other function. If I say is empty, so is empty is I have already is empty method is boolean. How can I say is this stack is empty? If I say return top equal to null, if top equal to null, right? Top equal to null. That means if it returns true, then it is what will be its top? If you an empty stack, then it has top equal to null. Initially, I'm setting null, right? So that means here is boolean is empty. It is returning. I'm writing in shortcut. Shortcut way, I'm writing what it is actually a boolean expression. Is this boolean expression will return either true or false, right? So if this top equal to null, that means stack has no object, no instance, then it will return true. Okay, then is empty method will return true. Okay, and then actually I need to pick. Let us do the simple method first. Okay, the pick method will return, you can either return ID or you can print the top node, anything you can do. Okay, so for instance my pick element over here is returning top.id. What is top? Top is a node, right? A node has an ID and a name, right? You can do anything. For instance, in the top method, in my top method, it has right now my pick method. It is returning ID, but instead of returning ID, you can say if you say void, and then you can say the top element has ID plus what is that ID will be? It is showing me error. Can anyone help me to fix it? What is my ID? Top ID? Top.id, right? Top.id. Oh, sorry, here in the beginning. Yes. In the beginning it is showing, but it is showing me another error because it should be top.id. Instead of name, I have to get this name as top.name or top. Because as an object, I do not have any individual ID. ID comes with node, right? Node object. What is the node object here? Node object is top, right? So then ID top has both ID and name. So this is why I have to access as top.id and name as top.name. That's it. So any kind I can, if as a top element, if I want to return ID, then I can do that. I can do public integer pick return ID, or if I want to print that void method, it will not return anything. Okay. Yes.
So are stacks and queues is two different methods of organizing a linked list?
Yes.
Okay.
Same thing, like siblings.
Two different ways of organizing.
Yes, to behave, they have different behavior. Okay. So then what other methods I have remaining? Push and pop, right? So let me do the push method first. I already have it, so let me get it and explain it. So the push method will add, this is my add method, okay? So this is, I want to make it as an argumented method. So I have two arguments, integer ID and name, and then before I push operation, I need to create a new node, because my initial stack is empty, right? My initial stack is empty, right? We are considering that our initial stack is empty. When you create a stack instance, then it will create an empty stack, right? So then in order to make a push operation, I need to create a node. So the node object, my node object, and the node object has this constructor. My node object has constructor. What is this constructor? My node object has this one, ID and name, and I'm setting up value ID and name over here. So just this ID and name I am providing over here. Whatever ID I want for this node and whatever name I want for this node, I will provide this, okay? And then what I need to do, okay, the operation over here, so when I create a new stack, I'm just making some, okay, when I create a new stack object, what it is doing, it is empty, right? This my stack, my S is empty, right? Let us see whether it is empty or not. Okay, let us print it. Let us see what value it has. If I print MYS, my stack, what it will print? See, I have nothing. It will print. What is printing? An empty object, but it is printing the memory address. Why it is printing memory address? Because I do not have toString method overridden for this stack class, right? This is why it is printing. It's not garbage, but something meaningless memory address. This is why we need to override.
Wouldn't you have to only override it though in the node class? Because the node is the class with the ID and the name, right? So wouldn't you just have to do it in the node class?
Yes, because I will print in every individual node. I will show you. Remind me later, okay? Why do I need this one, okay? Remind me later, okay? A few minutes later, remind me. Then I will. Can you please give me a favor? It's big here. Yeah. No. Yeah. Can you please come forward? No. Yeah. You. Yes. Yes, you. Yes, number 8 on your. Yes, you. Yeah, please come here. Okay, so I have empty, right? So it means I have empty. So, so realness. So for instance, now I have this. Let me see. Now I have this. So when I create a new my stack, so that what it will do, it will create me a new stack empty. Okay, so this is the entire is my S, MYS, my stack. It has name. Okay, the entire is empty, right? Okay, then what it will create? My node Okay, node will create, this is empty. So then when I create a node object over here, so then it will create a node object, node here like this one. This, here it will create a node. Okay, this is my node, and then this node will contain my value, whatever I put, for instance 1, my ID, and AA is my name. If I put AA is my name, okay, so then it will contains this AA my name, and then ID. Okay, so then what, after I putting this, what do I need to do? Okay, I need to do node.next. This text is coming up according to my drawing. So this size is block. So then this one, so every node, for instance, when you create a new node, it is creating a top equal to null, right? It is creating, when let me show you. I will show you that when in my stack class I have a constructor, that constructor is making top equal to null, right? Remember me at the top, I will show you later. So this is why I need to update my top. So in order to update my top, that last line, I need to put next node dot next equal to top. So this is my node. This node has a next. So this node dot next. This node dot next. I have to put next equal to top. What was my top, initial top? Null, right? So this top will be null. This top will be null. Okay, this top will be null. Initially this top will be null. Okay, and what was my initial top? That was initially null, right? So then I am putting this top equal to this node. The initial top was null, but I am putting this top equal to node. These two lines are what it is doing. Let me write it down. So that we can remember. Okay, so we can remember this. So I am doing node dot next equal to top, and then putting top equal to node. Why I am doing? Before that, previously I had my top equal to null. Let me show you now. I had my top equal to null. You see, when I create a stack element, an object, it initializes all top equal to null, right? But when I put an element, push an element, I need to change this top. This is why, since my top was null, so this is why I am putting node dot next equal to top means null. Initially it was null, right? So that I'm initializing node dot next equal to null. Actually, what it is going for the first element, it is going to equal to null. And then I had my top equal to null at the initial or empty stack. But since I have added one element, so then I have to put top equal to null. So if you do not understand, let me make some spaces in order to explain, in order to show this in one line. Okay, let me just create this empty space so that I can show you. You see that stack equal to top equal to null, right? So initially top is going to null. So then when I add a new element, my top needs to be updated with the node. Okay, so in order to do this line, actually what I am swapping. So in order to swap, we need a third temporary variable, right? That we are using the swapping method over here. So I'm putting node dot next, okay, equal to top, okay, and then I'm putting top equal to node. Just this is not swapping, actually this is updating my top. Yes. Yes.
So like, I was just confused why you do node dot next right there, because since you're pushing, you're adding an object to the stack, right?
Yes.
So when whatever is on top, so whatever's on top is null, right?
Let me do again this way. So when I have an empty stack, nothing in it, okay? Nothing in it. So what is top? Null. Good. Top is null, right? My top is here. Top equal to null, right? This top equal to null, that means it has nothing above it. This top equal to null means it has nothing above or below it, linked it, right? Okay, then when I add an element, when I add a node, then what will happen?
Then it won't be null.
No, this null, there is a node.
Yeah, there's a node.
Okay, but this node has data, but its next has nothing.
It's null.
Okay.
Oh, okay, I see.
Understand?
Yeah.
So when I add something, so then it has something, then its next is null. This is why I'm putting node dot next equal to null. Right? For instance, this line I'm putting node dot next equal to top. That means I'm putting node dot next equal to null, and I am putting top equal to node. This time top equal to node, right? Because I already have a node. So that node is the top node. Everybody understand? This you have to think critically. Okay. So that my goal was to do this line. My goal was to update this top. In order to update this top, I had to do this one as well. You will understand this one? Okay. So this is bottom is null. Bottom will say null. Now this time it says is this item's bottom equal to null. Right? Okay. Everybody is clear? Okay. So this is my push operation. Okay, and I need one more operation that is called pop operation. So pop operation is easier. Okay, so pop operation is a bit easier. So what do I need to do? Only I need to do this line. Only this line. I need to do only this line. This is the only line. Only this line. Let us understand why this line is doing. Okay, I am adding these two lines just in order to print this. Pop the node with ID equal to, okay, ID equal to ID. What? Yeah, ID equal to ID, or these are okay. But I need only this line. In order to pop, I need only the line number 48. So now let us understand what is happening on line number 48. Okay, so let us go through the block diagram again. So when I have When I have only one element, for instance, let us try with one element. When I have only one element, or two elements, three elements, as many elements as you want, same thing. So then what I had, when I have some elements in my stack, then I can pop, right? If I do not have anything, then I cannot pop, right? Remember, so I could write more code over here. I could get more restricted code over here. If top equal to null, then return. I could add this. If top equal to null, then I could add this. I will add this later. Okay, then after that, what, for instance, I have one element. This, for instance, I have this element. Okay, so this element, okay, so it's, what is next to this? This next is null. It next is null, right? So for instance, then if its next is null, and if I have another element, then who is next to this? If I have my A element over here, if I have my first element over here, for instance, my first element is 1 is here, and 2 is here, and 3 is here. So if I pop the last one, if I pop, then definitely the last one will be popped, right? Okay, so then if last one, okay, so when I have this, okay, think about what happens after push operation. So after push operation, my top became null, right? My top, this one, top dot next became null. This one, this it is top dot, this is the top, right? It says top dot next equal to null. Right? This one, this dot next equal to null. This next will come this way, upway. It has nothing. Top dot next, okay, this is null. Okay, so then when you pick this one, when you delete this 3 1, right? So then their entire this top will come here, right? Will move here. If you delete this part, if you delete this node 3, then your this one will be topmost node. Node 2 will be topmost node, right? So this is where here I am making top equal to top dot next. Because when my top, okay, when 3 was the top element, that next was 2. Okay, so next to 3 was 2, right? And next to 2 was 1, and next to 1 was null. For instance, this way. And then if I am picking, I am popping this third element. For instance, this element. If I pop this, if I delete this, then what will happen? Then I have to change my top from here to there, from 3 to here, not 3. This is why I am making top equal to top dot next. Because when I had third element as the top element, if I delete that, then I have to go to the next element. This is my top element. So this is the one line, single line I need to do. This is the single line I need to do. And other lines I just read it, I just added it in order to make a print statement. Nothing else. Yes. This one? So actually, so when I have an empty stack, I had nothing. Push. Push operation? Push operation is here. Okay, the push operation has 3 lines, but pop operation has only 1 line. But you can add some extra lines. For instance, if I say if top equal to null, return. I could say this one for more secure, because if there is an empty stack, it cannot pop anything. Okay, that's it. That's it. Now, if I have this one, now let me get my some code. So then I can say my stack. So my stack dot push one AA with one with ID and A is value name, and then at the second I put 2 with BB name, at third I push 3 with ID 3 and name CC, and fourth ID 4 and name DD, and this. And now if I do my stack dot display, oh, I need the display method. I deleted display wall nodes. I also need the display wall nodes. This method is same, exactly same. I got it from my linked list operation. In order to display, I need the display method. More display wall nodes. Then I'm sorry, what is that error message? The method main cannot be declared as static. Static method can only declare this top level. Maybe I messed up something. Let me copy this code. Okay, so I have pushed 5 nodes, and then after pushing 5 nodes I am displaying, and then after displaying I just did 2 pop operations. So then the last 2 will be popped. What are my last 2? 4 and 5, and after popping 4 and 5, it will show me, my display wall methods will show me the remaining 3, 1, 2 and 3 nodes. So you see, initial my stack, ID 5 name E will be the top one, and the next will be DD. Okay, and the next will be CC, the next will be BB, next will be AA, and then after AA next will be null. Okay, then after I do 2 pop operations, what events will be popped with ID 5 and ID 4, and then I will have 3 elements, ID CC, DD, and CC, BB and AA. The entire code is in my GitHub project. Just get it and do some practice. Okay. So anyone has any question about stack operation? Okay. So then if it's good, then let me go through the next one, and the last one for today is my QE. Okay, QE is a just line. When you go to a ticket counter, Just the person who goes first and gets the ticket first, right? Okay, FIFO type, first in, first out. Okay, it has like stack. It has only two operations. One is add, another is delete. The convention is that in QE, the add operation is called NQE. NQE means enter or add an element in the queue, and DQE means delete or remove an element from the QE. Okay, what is the main difference between a stack and a QE? Yeah, in a stack, the element that you enter last, you pop that first, right? You push that last recently, it will be popped, okay, lastly. But QE, the element you enter first, that will be popped or dequeued first, reverse order. So the implementation is little bit changed. If you understand the operation of stack, then it will be easy for you to understand the queue operation. Queue operation has only two operations: add element and delete element. Okay, so add element and the last step. This is the pseudocode. Actually, the last element will be add and delete. Add is called NQE and the delete is called DQE. So in my GitHub project, if you go to the GitHub project, okay, so it has also the QE program. So I have the QE program here. This one, okay, QE implementation. The package is QE implementation. Okay. So this program, if I run this program, let me run this program quickly. It has same thing. Okay, that this node class is same thing from my LinkedIn link class. Not LinkedIn, sorry. Linked list class, and then QE it has, okay, another thing that like doubly linked list, has two nodes. One is called previous, another is called next, post, previous and post, right? So that it has head and tail. It has one more node extra. QE has one more node that is called tail. Okay, and then initially in the constructor, I need to make head and tail both null. Okay, and so it has isEmpty method is same, either head is null or tail is null, then it will be empty. And then if you want to pick, okay, so that same pick method you can implement here. Same pick method you can implement here. Okay, you can say pick means top.id. I think I don't need pick over here. Actually, I don't need pick over here. So pick means actually the first one it will go. I don't need this one actually. Okay, so then two major methods over here. Only two methods I need here. Only is NQE, that means add method, and another is DQE, that means delete method. The NQE method is same, almost same thing, like almost same as stack push operation. Okay, so then the stack push operation, what did I have here? So I am creating a node equal to new node with ID and name. I have same thing here, node equal to new node ID and name. So this line is same. And if I have head equal to null, that means my queue is empty, then I will put head equal to node. Okay. And if tail dot equal to null, then I will go tail dot next equal to node. Why do I need this one? Because unlike stack in QE, we are adding a an element in the next, right, at the bottom. Our stack had, when we discussed our stack, we said that our stack had one side closed, right? So all this push operation came this way, and pop operation also went same way for our stack. But for QE, for our QE, we have this side is open. Okay, so whatever my push operation is coming this way, and also my pop operation, okay, also going this way. So push operation, you are coming an element this way, okay, and it is going out that way. Here is the basic difference, right? Because QE is the person or the entity or the object or the node, whatever you say, that will come first, will leave first. So that means if my tail is not null, that means I have something, or my tail, okay, the tail dot next equal to node, because here, okay, so here what I'll do, when I add an element, when I'm adding an element, then this element will tell whoever is coming next to me, take place here, next to me, right? So this is why it is doing tail dot next equal to node. Okay, so that means if I had already one node, okay, so then this is the thing that I have already one node, then it will tail dot next equal to next equal to node. It is coming over here because, okay, the initially same thing for the stack. Initially my node was empty when I created a new node, and then this is the actual main line. It's updating the node. If I have more elements, then says tail equal to node. So then if I have one more element, then this cell says tail equal to node, because here remember that what was my initial tail in the constructor. In the constructor, my initial both head and tail was null, right? Both head and tail was null, right? These were both are null. So but when I add an element, I have to update my tail. Then I will say tail equal to node. But here in my stack implementation, what I am doing, same thing, either top or say tail, same thing. Top is means head. Okay, I'm saying top equal to node. And here, since I am adding in different way, so in the then I am putting what is that called? Tail equal to node. The difference we have between stack operation and queue operation is that this top means actually top is, what is my top? Top is node, right? Top, instead of top I can say tail, head. Actually this is top means head here. Instead of I will tell you. I will see your answer here. On a second. I could say top. I will answer your question in a minute. I could say top. Yes.
So I see in the InQ method, if the linked list is longer than one element, we'll put it switches the tail to, it moves the data of the tail to the node above it, and then change the tail to the style you desire to entail. So,
Actually, I'm telling you, actually my actual code is this line.
yeah, so you're changing tail, which is the last element, if you could see it like that, to the data, the value you want. However, when it says tail.next equals no, does it move every element value up in the?
No. Every elements are getting on his position.
I guess what I'm asking, you have a linked list of say 1, 2, 3, 4, with 4 being the tail. You want to introduce
Another
you
one.
want to include the node 5. So you're at okay, never mind.
Confusing, because this is why I like you either to print these two methods to complete program and put this side by side, this slide, or write this pop push method in one piece of paper and then in queue method in another piece of paper, and compare these two. Okay, and compare these two, because you see that here the difference is minor, because I'm changing here top equal to node right here in my push operation, but in QE I'm changing my tail equal to node, and then these are actually for checking empty. Actually these two codes I could give also over here. I could give over also here. I could give node dot next equal to top. You said node dot node is node, is tail is means node. Dot next equal to what is that? Is top since okay. So this line is actually, this is the main line, because by these I am telling that whoever is coming, please come to my next side. Come next to me. I know it is confusing. So what I recommend you, so please at least write down these two methods, okay, in two different pieces of paper, and then put these two paper side by side, and draw a stack on the stack paper and a queue another paper. Yes.
So like right there, so tail is your last person in line.
Yes.
And then tail.next is the person that comes in after them, right?
Yes.
So why are you setting tail.next equal to node when it's like in the stack one you set it to top, which was null. So why was tail.next?
I'm telling that if there is a person here, there is one node in my queue already.
Yeah.
Then that means tail is not null, right?
Correct.
Okay, so then if someone comes, then if there is nobody in my queue, right? Okay, then my tail is empty. Okay, tail is also empty, right? Tail is empty, right? Okay, so but if I have one person, tail dot next tail not equal to null, that means I have a person. Okay, I have a node, at least one node, right? So then if I have one node, okay, so for instance, you are in a queue, right? If someone comes here, okay, then where you will take place? In front of you or and behind of you?
Behind.
Okay, so how you will tell that? That node, that next one is coming as a node, right? Okay, you will come there, okay, tail dot next, okay, so they will call that, okay, so this is, you will, my next person come to me, next to me.
But so like say there's one person in line, right?
Yes.
So and another person comes and you set them equal to that new node that you made, right? So the next person that comes behind me, they're equal to that new node that we just created. So say
okay, the next person will come to you, okay? So then when the next person will come to next to you, then he will be ready to tell the next person, come to next to me.
Yeah, so say I'm tail right now.
Yes.
And I'm ID 1.
Okay.
And then but you're saying tail dot next is equal to the node. So say so the next person was 2. We passed 2 to that node. That was the data with that node, right? So I'm ID 1, they're ID 2. because they're tail.next, and we set them equal to,
tail.next equal to node.
yeah, and say we pass 2 to that node. But to my node, we pass 1. So I'm ID 1, they're ID 2. But then you're saying after that, tail is equal to node.
No, I'm confusing. Do we pass ID or value? We do not. You do not pass ID or value. You keep your ID and name with you. Just you say pass the pointer. Just pass the pointer. Who will be next to you?
Yeah, I get that. But
Okay.
I'm saying, like, you have node, so you instigated an object of node, right?
Okay.
And you pass ID and name. Now, you're saying that node is equal to tail.next if there's a person in line. But you're saying, even if there isn't a person in line, that tail is equal to node. So you're setting your tail equal to node, and you're setting your tail.next equal to node. That means won't tail and tail.next have the same values passed to them?
Let me see. So I'm confusing too. Let me see it again. Let me see it again, and if there, let me see the program runs, and then if it its time is over. Next class I will discuss this. Okay? It is confusing, really confusing. It's confusing me too. I will sit with a piece of paper. Let me see what happened. So ID equal to 3. Okay. So ID 1 equal to. Let me see my program first. I have enqueued 5 elements A, B, C, D, E. Okay. The ID name next will be B. B next will be C. C next will be D. D next will be E. Okay. And E next will be null. Okay. And then I have dequeued 2 elements. Dequeued 3 times. Okay. 1, 2, 3. So then what will be deleted? 1, 2, and 3 will be deleted, right? Okay, and then I will have 4 and 5. Okay, the program is okay. Program is running correctly, but you should be confused. Okay. Here, this one, right? NQ. Okay. Here is our confusion, right?
Yeah. Do you get what I'm saying though? What I'm asking?
Okay, now let me give next class. I will make this part again. Okay, and let us do a sorry. This one?
Yeah.
Okay. Yeah. Let me try. How can I explain easily? Let me think it, and then in the next class I will do it. Okay. So everybody, please give me a favor. Okay. So please download this entire 2 programs like linked list, stack, and QE. Linked list has 2 linked lists. Okay, singly and doubly, and it has stack and QE. If you understand these 4 things, okay, then you will be good. You will be in good shape. Thank you so much, and have a good evening.